Now in this lecture, we're going to study about some of the major components that make long-term evolution, LTE mobile communication possible. And these are listed right next to me. OFDM, OFDMA, MIMO and precoding, handover and packet forwarding, and MBMS. First is OFDM, orthogonal frequency division multi-carrier. Now, in this part, this is dealing with carrier data using closely spaced orthogonal subcarrier signals, as you can see in the picture over there. They are very densely located. In traditional technology, what you would do is you would separate these main lobes far apart because there's main lobes and also they have side lobes. Each one of these have smaller side lobes. The main lobes are only shown in the picture over there. Now, normally what we would do is we would separate them out much further. But in this technique, we put them very densely together and still we are able to communicate very effectively. OFDM is strong against severe channel conditions such as narrowband interference and frequency selective fading. And this is very important because now we're using our bandwidth, we're using our signal bandwidth to support many users. And also we have neighboring mobile communication cells that consistently are providing interference. So we want to be able to cancel out narrowband interference and also frequency selective fading. In addition, we need to achieve high spectral efficiency, and that's what is possible through OFDM. High spectral efficiency and simple channel equalization is possible when you're using OFDM. Another one is OFDMA. It sounds almost similar to OFDM, but there's an A at the end. This OFDMA stands for orthogonal frequency division multiple access. And what you're doing here is, it's like you're using OFDM, but you're assigning some nets of subcarriers to multiple users. In other words, look at the picture over there. It's like an array, like a matrix with a bunch of these blocks, and you have these blue colors, orange colors, red colors that are in there. And they represent where user 1, user 2, or user 3 are assigned within the time and the frequency shown over there. Now, OFDM-A enables adaptive carrier allocation, high spectral efficiency, and little interference between subcarriers. And that's why it's used in LTE mobile communications. The next one is MIMO technology and precoding. Now, what is MIMO? MIMO stands for multiple input, multiple output. This enables reliable operation, large spectral efficiency, and increased data rate by using multi-path signal propagation based on multiple antennas at the transmitter side and at the receiver side. So, if we were to take a look at our E node B, which is our base station here, then assuming that we have a MIMO channel in between, the other end is our UE, user equipment, like our smartphone. Now, what we're going to have in the middle is our wireless communication channel down there, which we are going to call our MIMO channel. What is happening here is that the E node B, which is our mobile communication cellular base station, our base station has multiple antennas that it's going to use. Our user equipment, our smart device, has multiple antennas also, and these multiple antennas are used to increase the data rate that is sent between the base station and the mobile device. So between the E node B and the UE, we are going to use multiple antennas. Now the key concept of MIMO is something like this. In other words, instead of using one antenna, if I were to use, let's say, 4 antennas at the transmitter side used at my E node B base station, and I use 4 antennas at my mobile device, my UE, then using the same bandwidth that I used for single antenna devices, by using 4 antennas at the base station and at my mobile device, I am able to get almost 4 times the data rate that I was able to get before, when I was just using one antenna each at the base station and at my mobile device. So using 4 antennas and special pre-coding techniques, then I can achieve almost 4 times the data rate exchange using the same bandwidth that I used before when I was using just one antenna. And that's a remarkable, remarkable enhancement. That's what multiple input, multiple output, MIMO technology is about. And it uses pre-coding. Pre-coding is used to map the modulation symbols to different antennas. So therefore, MIMO transmission technique and pre-coding makes LTE very high data rate exchange possible. Then comes handover and packet forwarding. This is another big improvement that was added to LTE mobile communications. Now, the source eNode B, which is the source base station, and then when I'm doing handover, I also have a target base station. So for my smart device, I'm connecting to my original base station, which I've been using this base station for communication. And now as I move to a different cell, now I need to make connection to another, my target base station, which is my target eNode B. Now in this process, as I move from one cell to another and handover occurs, well, the source eNode B decides handover by sending a handover command message when the signal of the neighboring eNode B is stronger than the current signal. So in other words, it's like this. I will look at both the signal between the mobile smartphone, the UE, and both base stations, my source base station, which I'm connected right now, and my next base station, which I may do handover to, which is my target eNode B. Then I compare the signal, and when this signal connecting to my target eNode B is stronger, then something needs to happen. A handover command is triggered. Now, during handover, data loss is prevented by packet forwarding features. And this is one of the good things about LTE. What does packet forwarding do? Well, when I'm connected to my source base station and I make a switch to my target base station, as you can see from this connection on the top, I switch to this connection at the bottom, then in between, there may be a moment when I'm not connected. And during this period is when the continuous data services, the data stream that I'm receiving at my mobile device may get disconnected. And these packets may get lost. Well, LTE does packet forwarding. And it prevents any packets from being lost by saving these packets that were supposed to be delivered to you through the source base station. They move these packets to the target base station. And once you make good connection with the target base station, these packets are delivered to the UE through the wireless mobile communication channel. And this is called packet forwarding. So no packets are lost. Now, but just because packets are not lost does not mean that there is an interruption time in between of the packet receiving sequence based upon a seamless operation. No, there may be a little bit of a gap in between, but still packets are not lost. And packets are not lost because LTE mobile communication uses packet forwarding. Another feature is MBMS, Multimedia Broadcast and Multicast Services. MBMS utilizes the efficient point-to-multipoint distribution feature of LTE for broadcasting. And this enables multimedia contents to be broadcasted or multicasted very efficiently in LTE. Now, so if you've been using an LTE mobile smartphone or mobile device, then you may have been wondering, how is all this good performance possible? Well, it's based upon these technologies. And in next lecture, I will give you more about LTE and also LTE Advanced. These are the references that I used on LTE, and I recommend them for you if you're interested in further studies. Thank you.